All right, now rational expressions or rational equations actually are very, very helpful in helping us to be able to find unknown lengths of sides in geometry, especially in triangles. So here we have a problem that's talking about triangle ABC is similar to triangle DEF. And if you'll remember your definitions of similar triangles from geometry, that means that their corresponding sides are proportional to each other. So, for instance, in our triangle ABC, this side A to B is corresponding or is proportional to this side DE because they appear, first and second in their naming process. So this side is proportional to this side. Likewise, side BC is proportional to side EF. So BC here would be proportional to EF. And then that leaves our last sides also to be proportional to each other. And I'm making tick marks, which usually means that they're identical. That's not exactly true here. I'm just showing you that which sides are proportional to each other. Now we can use this information to help us set up a ratio of these two triangles. We can say that this side that I've marked in red is proportional to this side that I've marked in red in the other triangle. Or we could say that x plus 11 can be compared to the side that is 8 units long. And then likewise, the side that I've marked in black here, we can also say is proportional for both the triangles. So since I named this big triangle first in my first ratio, I have to name it first in my second ratio also. So that would be side 10 could be compared to the side x. Now, what we have done is we've created a proportion here. So we're saying that these comparisons are equivalent to each other. And by doing that, now we can solve this rational equation. So since this is an equation, we can multiply through by the common denominator, which in this case would be 8x. I'm going to multiply both sides by 8x. And then on our left-hand side, the 8's will cancel, which will leave us with x times x plus 11 equals, and on the right hand side the x's will cancel, which leaves us with 10 times 8, which would be 80. I'm going to go ahead and just do that one out. And now we can distribute here. So we have x times x is x squared plus 11 times x equals 80. Now this is quadratic because of this squared term here. Quadratics, in order to solve them, we need to be able to factor and set them each factor equal to 0. So we're going to move our 80 over. So we have x squared plus 11x minus 80 equals 0. And then to factor that, let's see, x squared will break up into x times x. We may have to think about the 80 for a minute, though. 80 could be 1 times 80. That won't give us an 11. Could be 2 times 40, but that won't give us an 11. 3 won't divide into it. 4 times 20, but that won't give us an 11. 5 times 16, there's our 11. If we did a plus 16 and a minus 5, that would give us a positive 11 in the center. And now we can separate out the factors and say, well then x plus 16 has to equal 0, or x minus 5 has to equal 0. When we solve each individual one, we get x equals negative 16 or x equals 5. Now remember what x was back in our original problem. X was this side length here. So there is no way that we can have a side length of negative 16. That's an extraneous answer. Our only answer here is x equals 5. But if you'll remember what the directions actually said, it was figure the length of AB and DF. So we want to know, what is DF? Well, that would be 5 units long. And then knowing that x is 5, we could say AB is 16 units long, because 5 plus 11 would give us a side length of 16.